So first of all, good morning, and thank you to Skills Matter for the wonderful space and to the organizers for having me today. My name is Riccardo, and here are a few notes about myself. I'll spare you the long story, but suffice to say that these days I'm having a great deal of fun working with a handful of friends to grow a fully remote and international development team whose aim is creating digital solutions for web and mobile, and the name is 100 Starlings. And that's all I have to say about it. But as you can see, my typical day is not very functional programming oriented. I do quite a lot of Ruby development, I do some DevOps, and plenty of team cons and mentoring regularly keep me away from Lisp fun. However, it is true that functional programming won my heart several years ago, and whenever I have the chance, I've been specifically looking at the Clojure ecosystem as a way to get out of my comfort zone, expand my knowledge, and ultimately get inspired. And that will be the theme for this talk too, as I truly believe that cross-contamination and bringing back to my daily activity those new inspirations eventually make me better at what I do. So if you want, that's the reference to the Odyssey in the title, but that's about it. So what are we going to do today? So I'm going to introduce a way to simply build cross-platform applications with a strong integration with the native environment, plus some highly desirable features that we'll see in a minute, using ClojureScript and other web technologies. Now, why? Why choosing hybrid, and why ClojureScript specifically? So web technologies are what I do. So when faced with the urge to scratch an itch, you would put it, those are the tools that I run to if I can. And sometimes you don't really need to squeeze every last CPU cycle from your machine, but it's still nice to have it tightly integrated with your environment, of course, and trigger that warm, fuzzy, native feel. Finally, I watched recently a presentation about Electron and just got fascinated by its architecture, and hopefully you will be too. On ClojureScript, well, this was a good excuse for me to keep my ClojureScript somehow fit. Also, I had this idea of using core async as an elegant way throughout the applications, but in fact, I just didn't need it in the few projects that I built using this stack. I wanted also to experiment with functional reactive programming as a concept, and I heard great things about Reframe. And finally, you know, it's Clojure, it's fun. Now, before moving on, I also wanted to give you my first advice. There will be a few hints scattered across the presentation. Here, I tried to best a learning curve on two fronts at the same time. On one side, Electron and ClojureScript integration, and the other side, functional reactive programming, which was kind of new to me. In my book, that's being a bad boy. So in general, please don't do that if time is of the essence to you. So pick your battles one at a time. You will be glad. Now, throughout the presentation, I'm going to make references and pick some other anecdotes from two actual applications that I built over the last year. The first one is an interactive WebGL installation, and the second one is a more mundane time tracker. FunBit, which is a WebGL one, is what started all this journey for me. But it is a fairly complex beast, and it would be quite hard to drive the point home with it. So the time tracker, although far less exciting, will serve us better this time. So if I do my job well, at the end of the talk, you should have an idea of where to look for a new stack to build desktop applications and all the steps that are required to get there, a wet appetite to explore further in this direction, and a few hints on which surprises may await you on the way. But if there is one thing you may want to take home, well, make it this. Keep a diary, or a project log, or a blog, or an org file, if you are into that. Even for pet projects, actually, in fact, especially for pet projects, it will be your ever-present rubber duck. It will bounce back ideas to you when you least expect them. And mainly, it will force you to streamline your thoughts and celebrate the successes. So I cannot stress this enough. This talk wouldn't exist without a project log. Now, here's where I try to give you a little bit more context about Clockwork, which is the simple time tracker we just mentioned. In essence, it's yet another boring timer, born as an experiment out of the frustration of not finding the right tool that would integrate seamlessly with the workflow of my team and adopt nicely across different clients, and because each client comes with its own quirks and preferences. That's the way life is. So after deciding to do something about it, instead of just adding yet another website to the already long list of tools that we use day by day, I decided to experiment with a little app that can live on the desktop, survive browser restarts, support global key shortcuts, offline, survive offline situation, etc. Plus, having that available locally in form of maybe an EDN file would allow for some clever automation later down the line. So coming to the stack itself, this is how it looks like pretty much. As you can see, we have a couple of extra technologies on the side called Desktop and Figwheel. I'd rather not dwell too much on them, so let's discuss them quickly. Desktop is a very nice line again template. You can use it to get started building Electron plus Reagent applications or Electrons plus OM applications. So the idea is still to pair Electron with some React wrapper. It also integrates nicely with Figwheel, which probably doesn't really need an introduction here. How many people here already know about Figwheel? Pretty much everybody? Yes, thank you. So that's what I've been using essentially to hot load the code into the app during development phases. Now, coming to the big one on the stack, Electron, it's actually the cornerstone of this whole thing. You can view it as a combination of Chromium views, which in the Electron lingo are called renderers, orchestrated by a Node.js process, which is called main in the language of Electron. Now, the main process has full access to the host, and that's the key thing. It's responsible, therefore, for native integration with the environment, like notifications, tray icon management, etc., and for dealing with and invoking and summoning the views themselves. The renderers on their side are responsible for presenting the application UI to the user. Now, these processes also communicate between themselves via built-in IPC mechanism, and it's also possible for renderers to get access to the main process features using a special module that's called remote. Now, this means that JavaScript running within the Chromium views actually can be granted full access to the host machine. Now, that's quite scary, but also extremely powerful. And finally, one more thing, always nice to have, there is a really active community around the whole Electron thing, and it counts a few big players like Slack and Atom, which is GitHub. Now, here are a couple of examples. So the first one is, here's the main thread in Electron initializing the whole app. We're taking here advantage of one of the built-in modules, which is the crash reporter. It comes for free. Just in case anything goes wrong, we can be notified about it. And the other thing that happens is that on ready, which is an event within the app, what we do is that we initialize our first renderer, and which in turn is going to include the styles and closure script that it needs to run its front-end application. Now, a side note, while we are essentially talking about web development here, don't be fooled, you cannot overstate the beauty of having to deal with just one browser engine and not having to deal with the browser wars. Here is the second small example, and it is an example of how the remote module is used. In this case, we just want to build a file path for saving the time slips. And what we can do is get access to the paths that are known only to the main thread. Coming to ClojureScript now. Honestly, I hope we don't need to cover any technical details about ClojureScript here. And in fact, most of you are way more knowledgeable than me on the matter. So instead, here are a few personal notes that I gathered while working on this project at hand. So first, what I noticed is I get far more attached to ClojureScript code than other code I write. That's just a fact. Maybe it's inner elegance that makes me narcissistically fall for it, or just the fact that I'm not as proficient in ClojureScript as with other languages. Therefore, any single line of code has a higher cost to me. Honestly, I don't know, but that's the fact. I also find it really harder to write page after page of boilerplate code in ClojureScript while my mind roams elsewhere, which is what happens sometimes in other cases, in other languages. But I'm also starting to think that that's actually a good thing. And finally, I find that on average, my ClojureScript code ends up having less shortcuts, being more explicit, and generally better than the code I write in Ruby or, God forbid, Java. Now, next tier on the stack, we get to Reagent. How many people here are familiar with Reagent as well already? Quite a few, okay. So what it is just it offers you a very, very simple wrapper around React as a way to manage your applications and flow. So it uses a hiccup syntax to describe the HTML. It also provides specialized atoms that can be used to handle the app state according to the React workflow. This, in the example, is pretty much as simple as you can get regarding a Reagent component. The today component is calling 3 other components and embedding them into a div. 2 of these are defined as elsewhere. And the debug.db component, the only thing it does is that it just outputs the current status of the whole application in a div as it changes over time. So coming to the pros and cons, I find Reagent to be a very good, simple tool to interface to the React concepts. It offers just about the right level of abstraction for me. And by default, I can rely on a very, very small API to exploit it. Nonetheless, there is much more that's going on under the hood. Cursors and trackable functions being 2 notable examples. So I strongly advise you, if you're interested in these topics, just go and look through the code. It's fairly small. And I don't really have any cons or grudges, but I can say that in contrast with the super minimal interface that it offers, getting a hang of the right way to define a component, meaning returning an array versus a function and when to do that, it required a little bit more effort and experience. But mainly, what Reagent did was make me realize that I really, really like being able to rely on a solid pattern when building an app. And the pattern is what Reagent actually doesn't give you. So how did you find that out? Because right after getting Electron to talk to Reagent the first time, I decided that I would have embarked in a quick discovery phase, and that brings us to discovery, or Walk of Shame, part 1. So the idea here was to get my basic functionality right in place and then slowly grow it into the real application. Now, that sounds like a good idea, but the reality is that I shouldn't have rushed to start building and spend instead more time researching the right approach. That said, a throwaway prototype would still have served the purpose, at the very least, to highlight the lack of a pattern. But my main mistake here has been holding on for far too long on code that was just not good enough. And did I mention how I get attached to my closure? Also, investing in code aesthetics in this early stage, which counts as premature optimization, as James was talking about earlier. Finally, I've been afraid of putting too many irons in the fire, namely introducing a good pattern, reframe at this stage. So I started modeling the problem in a functional reactive programish way, but directly in Reagent. Now, nothing bad with that. It's a fantastic tool. It can totally do it. You're more than welcome to try that. But for me, that meant spending precious prototyping time reinventing the wheel, essentially, and frankly, coming up with something that was not exactly standard, nor particularly great. So lesson learned, hopefully, for the next time, using Cljs and doing exercises to learn about things, and then using all of your tools to actually prototype and build the solutions. But there were a couple of really useful outcomes out of this phase. One is that I introduced and refined into my tool belt the use of ComDev tools, the ClojureScript version. So extremely useful. And I started doing a really simple trick, which was injecting the app state in the view itself, so that I could keep an eye on that all the time without having to interact with it via the REPL, and the saving in time has been incredible. Now, coming to the other major element of the stack, reframe. Anybody played with it? A few people, okay. So long story short, what reframe offers is a pattern to write functional reactive programming apps in ClojureScript over Reagent. So, as mentioned in the GitHub page, that's a bit of a mouthful, but it's actually MVC, just not as you know it. It provides a different way to organize things, but it actually makes a lot of sense. And to me, the main attraction was that it allows you to write pure functions throughout most of the application, and therefore making your code easy to describe, to think about, and to test. Meanwhile, reframe takes care of all the ugliness that's hidden underneath, and namely dealing with side effects. Also, reframe offers a convenient way to think about how the data moves around the application in a unidirectional, simple way. And finally, again, it's a really, really small library with a minimal API. And what is big around it are the ideas and the conventions that go around it, and essentially the pattern itself. But the code is really, really minimal. So what do you need to do to build a reframe app? It's basically 4 steps. You first design your app application information model, so data modeling here. Then you kind of write and register the subscription, the ways you want to slice and dice your data model. That's a query layer for you. Then you write your reagent view functions to present the data to the user. And finally, you have the control layer, which is all the event handlers that allow your application to evolve and respond to interactions. So, modeling the data, also known as work of shame part 2. What happened at this point is that I decided to mimic the system we were already using for time tracking, and taking for granted that its data model would have been a good fit, without stopping to really think about ways to optimize and simplify. So next time, lesson learned, more hammock time for me. What I ended up with was a perfectly working model, but with a lot of unneeded complexity buried within. For example, the extra state required by mutable timers. You don't really need them if you need to track time in real time, and especially you don't need timers that can be activated in the past, which is kind of weird. Now, another small wisdom pill, hopefully. They say, don't be afraid of throwing away stuff. I find that fear is actually the easy part to conquer. Stubbornness and pride, for me, are much harder beasts. And also not get sniped into making something ugly work at all costs. So, by the way, Chris was saying yesterday about data modeling being the the real advantage of enclosure, and I totally agree with that. It's where it really outshines all the competition. You just really need to let it sink and do its magic. Now, coming from to the view layer, which is the second layer, and I need to speed up a little bit. Here's where we use Reagent, essentially, to present our UI and feed it with data from our application state according to our model. So WeFrame lets us easily subscribe to changes in the app state in order to, let's put it this way, in order to repaint the affected components. As a bonus, that helps a lot in constraining the complexity that goes into the interface. So for example, a way to look at it is that you may want to split components on the concept of what is changing exactly here. If an element needs to be updated more often than its immediate surroundings, to me it's a smell that probably a separate component is needed at that point. So also keep an eye open for states that can be kept local to the component. For example, real-time validation of an input string. That gives you the chance to reduce the major upstate noise and an opportunity to shy away from, again, premature optimization. There's another side to the user interface. This is not exactly your average website, so we also need to think, we need to bear in mind that this is an Electron application, so it's native, and its tentacles reach really deep into your desktop experience. So multiple tabs, tray icons, badge, status bar, integration, notification, all of these need to be dealt with separately. Usually that happens in the main thread, so it's a separate process that's taking care of them. The good news is that they are mostly just side effects, so WeFrame, in this case, is offering you, us, a nice way to deal with those. Now, coming to the query layer, now having the data model on one side and the views on the other, we know it's now easier to identify the subscriptions. So the way to slice and dice information so that we can feed that data into the views. Now, when thinking about subscription, I find it really useful to think of them as belonging to two subgroups. There is a direct way of grabbing data from the app state. For example, in the active day, you can see it's just getting a part of the map. But also you have the opportunity to apply transformations to it. And in the case of the active day time slips, we are actually keeping an eye on two separate aspects of the app state and transform and derive the data after when something changes. Now we get to the last part of the of our stack, well, of our WeFrame stack, which is event handling. So this is where the application has a chance to change its state. It's also where I find most of the magic happening, and most of the magic comes from the fact that event handlers can leverage what WeFrame calls interceptors to masquerade some of the side effective logic that goes on underneath. So in particular, you get to use what are called core effects that are defined in the first section of the code there to make data available to the event handler. For example, reading the system clock or reading configuration file. And then you get to output effects, an effect map, which is actually a way to make side effect inoffensive by turning them into data. Now, typical examples in this case are app database mutation, so mutating the state, or dispatching another event like it's happening in the bottom event there. So now this is a really, really clever way to do things, because, to me at least, because it keeps the event handler as pure functions, and that's priceless, as we already said. It makes everything simple to understand, text, test, and explain. There is also a what moment here, and that comes when you realize that to do something as common as periodically saving your app state to disk, you need to first set an interval function that dispatches an event that will be caught by an event handler that will call an effect handler that eventually does the saving. But maybe that's just a sign that I/O is never trivial and you should really handle it with care, regardless. So here's what I got so far. It isn't pretty. It does the work. Is it ready for wide distribution? Well, definitely not. So what next? There's plenty more effort that needs to go into an application like this at this stage if you plan to make it App Store ready, which is what I'd like to do, at least as an experiment. On the packaging side, the app, for example, requires a decent, good app icon. To properly navigate through its features, we will need to trim and adapt the menu structure and keyboard shortcuts, and maybe add a status bar indication or an icon badge at the bottom, so integrate more with the surrounding environment. We will also need to think about the extra content that needs to go with it, so not just within the application frame, which is what we are used to when thinking about web development, but also the help subsystem, the about frame, and all the things that come in that direction. And also, as I briefly mentioned before, we really need to think more about security. And both internally, to make sure that our processes cannot harm anything on the host machine, but in the case of macOS, also signing the package to make our Cupertino overloads happy. Thinking about future-proofing the application, you also may want to take more advantage of other freebies that come embedded into Electron, like the crash reporter that I already mentioned earlier, the auto-update feature. They all can bundle in. They also comes with default implementation of the server side. So it's really just a matter of having the server available to accept your crash reports or to dish out update releases, and you will be good to go. Now, that's it, essentially. So here are a few references to all the technologies that I mentioned during this talk. And that's all I have for now. You'll find the slides for the talk at the GitHub address above, together with the application itself, if you want to play with it. Pull requests are welcome. I will keep updating it in the upcoming weeks, as I will go through those last mile to get the actual app into the App Store. So you may be able to find it for free on the App Store soon enough. But I don't expect to support it really after that point. After all, it's just an example to understand how to get started with this sort of application. So again, thank you.
Thanks very much, Riccardo. Any questions at all for Riccardo? Oh, no. Very good. Oh, yes. Behind you.
Do you have any basic examples of just using Electron?
Sorry, say again?
Do you have any basic examples using Electron?
So without the ClojureScript side?
Well, with ClojureScript, possibly so without reframe.
Out in the wild, well, actually I think Lightable is an example of a ClojureScript-based application with...
sure, but it's hardly a tutorial. It's quite a complicated
It's hardly a tutorial, yes. But that's the main example I know about distributed, publicly available ClojureScript application. If there are any other examples, please point them to me, because I could benefit of them as well.
Right. Okay, thanks.
I'm confused. Maybe you can help me clear up my confusion. Every time I've looked at Reframe, it seems to be saying it's about pure functions, but it seems very, very stateful, very magical.
Okay.
Can you help clear up my confusion?
Okay, so again, I'm not real expert, so I've been playing with it here. But from my understanding, what it does really well is hiding the magic. So what the API is entirely functional. So what you get to write are purely functional. Pure functions. Then, of course, what happens underneath? So what Reframe takes care of is conveying the data around and hiding basically all the naughtiness and complexities of the side effect. So that is my take on it, at least. Does that answer your question? We may want to talk about that later? Yes, okay. I'll be interested to know about your thoughts as well.
Sleepy Fox, Nigel.
Hi, have you done any Electron development just using plain JavaScript?
Just using?
Plain JavaScript.
Just to experiment with it. So
okay. How would you characterize the difference of building an Electron app with just plain JavaScript versus your experience of building on top of ClojureScript with Electron?
Okay, so I had an assumption that then wasn't really confirmed. So as I mentioned earlier, I was expecting to use a lot of core async to piggyback on this IPC thing that goes on between the renderers and the main thread. That actually didn't happen much, but that's just because, I suppose, because my application were not that complex. So I didn't get to that stage. It would be extremely interesting to try to verify that, if it can make a big difference. Otherwise, my main take is that, let's put it this way. I find ClojureScript much nicer to deal with in general, okay, but especially when I have to reason about the React models and this functional reactive programming model. Doing the same thing in JavaScript, I couldn't find a similar elegant enough, simple enough, cute enough library that does the same thing. So that would be, it's really personal. So I really find it easy to reason about, more effective, and more elegant in the end.
Any other questions? I mean, just to echo that, I mean, when we were doing the React and ClojureScript tutorial a couple of weekends ago, Hack the Tower, we did see, so like they kind of showed us some of the JavaScript we'd have to use in this tutorial, and that scared me, because it was like JavaScript in full effect. And but then they kind of showed you how to wrap, with just a couple of functions, wrap away and abstract away, essentially, to hide away what React was doing, or what you were doing with React. So you had a couple of JavaScript interoperability calls to use React from ClojureScript, but everything else was, but they were wrapped by two ClojureScript functions. Then everything else you were writing were nice, clean, simple to understand Clojure functions. So I think it's quite possible to hide that away, just like you would hide away kind of I/O or any other stateful stuff there as well.
Are there any experience with ClojureScript, how well it is working? So in a perfect world, everything works well, and then it's like better than JavaScript. But if you run across problems where something isn't implemented very well or so, and then you have to program around that, maybe it was a pain at a certain time, or still is.
Maybe.
That's a good question. I mean, again, I'm not a ClojureScript expert. Welcome to kind of get some feedback from anybody else who is. But yeah, when we first tried it, I think that was maybe 2012. Yeah, it was horrible. It was like, what? You had to actually know, you had to be a JavaScript expert to actually understand how to use ClojureScript or get it to work. In the last 2 years, I think it's become a viable language. I mean, like with any young language, I think there's still going to be, you're going to find some issues. But I think there are companies now that are using ClojureScript in production, so it is viable in that sense. But again, your mileage is going to vary depending on what you're trying to do with it. So, cool. Right. So there's no more questions. So I think everybody's dying for lunch. It looks quite a nice lunch. So I'll let you go. Just one quite quick mention, as well as the feedback. Please give your feedback for Riccardo. So thank you very much for Riccardo again. And yeah, so break for lunch. We have found several items of lost property. So if you've lost anything, any small jewelry items or watches or anything like that, we have a few small collections of things we found.